Alright, so in this video, I'm going to talk about the activity series used for single displacement, and then I'm going to use the information to work on the predict product worksheet number 3, which is the single displacement. So first of all, the activity series is like very similar to the metal reactivity, non-metal reactivity, but it's not exactly. So you want to just use activity series for single displacement. Single displacement is recognized is like 2 to 2, and then it has a compound element. So basically what happened is the single element will come to kick the element of the compound out. So the C will come to kick the A out, and then the C is going to react with the B in the reaction of like the A is the positive, the C is the positive. So they're both positive, they're both metal. So the C will come to kick the A out to replace, and then the C is going to react with the B because the B is a negative, so positive, negative. So the C must be strong enough to kick the A out to the outside. So how do you know that the C is strong enough to kick the A in order to say we have reaction? Or the C is not strong enough to kick the A out in order to say that there's no reaction? You're going to use this activity series. So the metal, you're going to compare with metal only. Non-metal, you're going to compare with non-metal only. But the way to do is the same thing. Now these arrows, first of all, they are by like the arrow is like both sides, okay? They're not just one direction. This can go back and forth, right? These arrows are called back and forth. It's not just one direction. Now on the top of the series, the element will be more reactive, meaning they're much stronger, right? They're taller, they're stronger. And the element on the bottom, they're least reactive, they are least stronger, right? They are less reactive. So if the one that you're going to replace, right, if the one that's going to be, I say, lonely element, right, this is the happy element, the A is happy, the C is lonely. If the lonely element is on the top and the happy element is on the bottom, then the lonely one will be strong enough to kick the bottom one out, to kick the happy out to here. Then the reaction will take place. If the lonely is on the bottom and the happy is on the top, the lonely one is not able to kick the A out because it's on the bottom meaning less reactive. Then in this case will be no reaction. So here the notes here is the top element can replace the bottom element, then reaction take place. You gotta write the charges and change in the identity, and then you gotta balance the equation. And the bottom element actually cannot replace the top element. So then no reaction, don't write the charges, don't write the balance equation. Okay? Now here again is if the lonely one is on the top, they will replace the bottom one outside. And same thing for the non-metal. The non-metal will be the negative thing. So we also have 4 elements in the series. They are halogen. You should have to memorize the state because on the test I will not give you the state, but you should remember these diatomic elements, okay? The first two, these two are the gases, and then liquid, and then the solid, okay? And then in the middle here, they all play with the hydrogen because the hydrogen can be existed in the water, in the cold water, in the steam water, or in the acid. So in the middle of here, the hole in the middle will be a web with the hydrogen because hydrogen can be existed in acid and water and the gas. So each element, they have their representation. So for example, this kind of element will react with liquid water or gas water to form hydroxide. This element will react with acid to form the salt and the hydrogen gas. You see that I give you some example. This element will work with water to form oxide and hydrogen gas. They will work with acid to form salt. If there's no liquid water in this metal, right? So you see that the liquid water shows up on the top, that means you have reaction. But if you have no water liquid shows up on here, that means there's no reaction. Right, so these metals, they react with acid to form salt. That means they would not react with water liquid or gas liquid. They won't have any reaction. All right, so same thing here, right? This all we have no reaction at all, no matter you put acid or water or gas. So all of them have the example here, and then all the acid will be given in this kind of acid form. Okay, and then on the bottom I have all the examples that I can think of. For example, the first one is the metal series reaction take place because the lonely can kick the lonely is above the happy one on the series on the top, so it can kick him out to form reaction. So Mg can replace Ag. Now this one Mg is below Li, so cannot replace, no reaction. Here we're going to use the non-metal series, so the lonely one is the Cl, the happy one is Br, so Cl want to kick Br out, and Cl is above Br from the series. So then in this case, Cl can replace Br and the reaction take place. And then here Br is below F, so cannot take place, no reaction. And then here is the water gas. Okay, so if it's a chromium, we find out with the water gas. Let's see if chromium have the water gas. So chromium has water gas reaction. They will form oxide and hydrogen. So if you look it up, right, we're gonna write, okay, they form oxide. They do form oxide and then hydrogen gas. Okay, they form oxide and hydrogen gas. So then replacement can take place. And then if the magnesium in water liquid, so magnesium in water liquid, because you cannot see water liquid here, that means there's no reaction. Okay, so there's no reaction, so then nothing happened, no reaction. Sodium in acid, so let's say sodium is right here. So sodium with acid, they form salt and H2 gas. So right here, they form salt and H2 gas. So the salt is actually separate the SO4 to minus. And I will work it out later. And for example, this one, calcium with water gas. So calcium with water gas will form hydroxide and H2 gas. So all the reason is right here, and you'll be given all of this thing, okay, except the state, except those the bottom thing, except those bottom. Other than that, everything will be given to you. So you're giving the example. So don't worry about you have to memorize what this will be produced. You will be given all of this. Okay. So now let's looking at the notes. So first of all, my sentence is lonely kick the happy out. Okay, the lonely kick the happy out. So the notes that I write here is you only write out the charges and you change your identity when there's a reaction, because you want to imagine that, when I need to have the reaction take place, I'm going to switch the identity. Right, I'm going to switch the identity from CO2 plus, I'm going to change to CO, or if I'm from CO, I'm going to change to CO2 plus. So I had to write down the charges and change the identity. And you got to use the series to check the position of which one is on the top, which one's on the bottom. And then when you have the water gas, water liquid, and acid, right? Water gas, water liquid, and acid, you're going to use those boxes here. And then if you have the insoluble product for the single displacement, we usually write solid. Okay, if you have insoluble product for single displacement, we write solid. We would not write PPT, because PPT is particularly for double displacement only. Okay, so let's do for all questions here. So first of all, this is single displacement because I recognize that they have compound and element. So the lonely one is the zinc, the happy one is Ag. How do I know? Because they are both positive charge. They must be both the same positive charge or same negative in order for you to compare on the same series. So zinc is the lonely, Ag is the happy one. So my sentence is lonely kick the happy out. So we're going to ask, zinc, would zinc be able to kick the Ag out? So we underline zinc and Ag, we're going to draw the arrow, and then we're going to look that up. So zinc and the Ag. Now the zinc is on the top, Ag is on the bottom. So when my lonely one is on the top, right, just like here, when my lonely one is on the top, so we will say the lonely is above the happy, then the lonely can replace the happy one, then the reaction will take place. So in this case, my zinc is on above the Ag. Okay, so my zinc is above the Ag. That's why zinc can replace Ag. In other words, I do have reaction take place. Okay, so in this case, I'm going to turn up to here. Okay, I do have reaction take place. So if we have reaction take place, I'm going to change my identity because they start to switch room. Okay, you want to imagine this person is a lonely person in the bathroom. This happy guy is in the ballroom. So they start to switch room. That means they switch the identity. Oh, this princess was before in the bathroom. He is a frog. Now he want to go to ballroom, become a princess. And the princess in the ballroom now need to go to the bathroom to become a frog. So they need to change their clothes. So the Zing, original Zing, right, we need to change the identity to be ZN2 plus. How do I know? Wait here. Again, this arrow will be going back and forth. This arrow will be going back and forth. So he was originally Zing, you gotta change to ZN2 plus. All right. Now this is a couple, so this is the prince and the princess. So before we switch partner, we have to separate them. We separate the prince from the princess. So we just rewrite them AG plus NO3 minus. I did not change your identity. I just separate them. I just separate them because they're aqueous. They're aqueous. I just separate them. So the princess stay in the ballroom. We are not going to change her. But the prince in the ballroom is going to ready to go to bathroom. So he's going to change his clothes. So AG plus, we're going to change back to AG because he's ready to change his room. So change his clothes. So for AG plus to change AG. Then now we can say the lonely kick the happy out. Right, he's gonna go AG to the bathroom at the end. So we're gonna write AG, and because AG is a silver, it's a metal, so we're gonna write solid as the state. And then the Zeng2 plus, the frog, right, is gonna come to the ballroom and dance with the prince. So the Zeng is the N2 plus, NO3 minus, the princess is the NO3 minus. They're gonna dance in the ballroom now. So then you cross over back to form Z and Benesis NO3 to aqueous. And then now, because you have reaction, you got it. The balance of the equation will be 212 to 2112. And then how do you know the state here is you got to check the solubility. You will find out that zinc nitrate is aqueous. So then this is the answer. Okay. Now I'm going to do the rest of the questions. Okay. So I'm going to do next one. PT and KNO3. So my only one. Okay. My only one is PT. My only one is PT, and the K is happy one. They're both metal. Metal I'm using red color, and then the non-metal I'm using blue color. Okay, so lonely kick the happy out. So PT want to kick the K, but we are not sure whether it will have reaction. We just draw the arrow, and then we're gonna look up the lonely one to see if the lonely one is about. So the lonely is on the bottom. The K is actually on the top. So we are actually following this situation. The lonely one is below the happy one. So the lonely one cannot replace the happy one. So then in this case will be no reaction. We gotta do the same thing here, okay? Because it does not have the reaction. Why? Because the PT is below the K. PT is below the K. So then the PT can't replace the K. So then no reaction. No reaction here, no reaction here. And we're not going to do anything. And this is it. Okay? Now we're going to do number 3. Now number 3 is be careful. Okay, we are not using red color because the lonely one is actually a non-metal. Cl2 is the lonely one. Cl2 is the non-metal halogen. So we're going to use the blue color. Okay, so the lonely one is Cl2, blue color. And then the happy one is not Li, the happy one is I, because they are both the negative. Okay, you can see that Cl and I on the same series. I cannot find Li here because Li is positive. So, lonely one is Cl2, I is the happy one. Lonely kick the Fe out. So we gotta ask, if Cl2 is able to kick the I out. We're not sure. So let's look it up if Cl is on the top. And so Cl is actually above the I. So if you look up, it's actually the situation, right? We do the negative, right? So lonely cat the happy out. So in this case, the same thing as number 3. Cl is above Br, lonely above the happy one. So then we can we can start the reaction, we can replace it. So right here, I'm gonna write the reason, okay? So Cl is above I. Cl is above I. That's why Cl can replace I. In this case, I do have reaction. I do. All right, so what's going on? Then they have to change the clothes. All right, so Cl2 and I need to change clothes, but Li doesn't need to change clothes. He's just, the prince is just stay in the ballroom. So Cl2, if you look it up, Cl2, we're gonna change that to Cl minus. All right, so they change to Cl minus. So we can change the clothes. Change to Cl minus. And then here, right, Li and I, they're couple. We first want to separate them first, okay? So because they're aqueous, we want to separate them first. So I'm gonna use Li. I'm gonna use a green color. We separate them. Li green, Li plus, and then the blue one is for I, so iodide, so I minus. I basically just take Li I, and then I just cross over, charge back. Right? Bring the one to the top and cross over, charge back. So here, Li plus will not change the identity. He's the prince in the ballroom. No one, he's not going to change his identity. But the I minus going to change the identity because he's going to kick out. So I minus, you got to change to I2. Okay? So we're going to write the identity. We change it to I2. Right? So then now we can take the I2 where, actually this is the blue color. This is the blue color. Blue color. Okay, so we're gonna kick the I2 out. Kick the I2 where? Kick the I2 to the end. Alright, so we kick the I2 to the end. Right, so I draw a line for coefficient I2. Now the I2 is a solid. Okay, I2 is a solid. So you should know I2 is a solid because here I'm giving you the solid, but on the test or the quiz, I'm not going to give it to you. Okay? So then now you kick the I2 out, and then the Li plus stay in the room, but Cl minus is going to come to dance with Li plus. All right? So Li plus stay in the room. Okay? Cl minus is going to come. Right, so green and blue color, and they dance in the black ballroom. They dance in the black ballroom. Right, they cross over, and then they will form LiCl. And then when I check the solubility rule, I found out that it is aqueous. Right. So then finally, I'm going to balance the equation. So you know how to balance the equation. I assume the answer should be 2, 1, 2, 2. Okay, so the answer should be 2, 1, 2. Oh, I'm sorry, 2, 1, 2, 1. I'm sorry, 2, 1, 2, 1. 2, 1, 2, 1. All right. Okay, now let's gonna go to the next question. So here is the lonely one is the non-metal. Right? Lonely one I choose a non-metal. So which one's gonna compare? You gotta compare the Cl because they're both non-metal. Lonely kick the Fe out, so I2 is gonna kick the C out, but we're not sure yet. Right? So we're gonna read to see if I2 is strong enough. Is on the top. So I2 is actually below Cl. So which is the same situation as here. Whatever that you want to kick, the lonely one is below the happy one. It cannot replace, so then no reaction. Right? So come up here, I'm gonna say I is below Cl, so then I can't replace Cl. So in this case will be no reaction, so no reaction here, no reaction here. And we don't balance it. And that's it. Now, I'm going to start to talk about the water, okay? So whenever you see water, liquid, water, gas, or the acid are this kind of the acid, you got to look up the middle part, okay? So let's say we're going to find K and H2O liquid. So we want to find out the, we need to recognize that we need to recognize that the K to see if it's a reaction with the water liquid. Now we find the K and then we find this section. Okay, K does have the reaction with liquid water to form hydroxide and H2 gas. Okay, so they do have the reaction with the liquid water to form hydroxide and water. The hydroxide and the H2 gas. So what does it mean? Whenever we have the hydroxide in the solution, we gotta split Okay, you're gonna write this. So this sentence, you can actually write it. Okay, so I'm gonna start right here. All right. So first of all, I recognize that this is water liquid. So I'm gonna highlight that water liquid. All right. Now, which one's gonna compare? We're gonna compare K with the